For our lesson today, we're going to be talking about solving two-step equations, and we're going to start with an anchor problem here, which is shopping for cookies. I go to the store to buy cookies, milk, napkins, and cups for a party. I need to know how many packages of cookies I can buy and still...
Brooklyn Hepton, come to the front office.
Sorry about that.
Hepton.
And still have money left over. I have $35.50 in my wallet. I know that I need 2 packages of napkins at $1.50 each and 2 packages of cups at $3.50 each. I need 1 gallon of milk for every 2 packages of cookies. Each gallon of milk costs $2.50. Each package of cookies costs $3. How many packages of cookies can I buy and still have money left over? So we're going to go into our lesson today, talk about our two-step equations, and then we're going to come back to this problem and see if we can solve it. So first of all, I want to talk about the parts of an equation. And there's a few key parts of an equation. First of all, right here, you'll see that we have our variable, which is just anything that represents a number, represents a quantity. Then we have our coefficient, which is the number that is attached to the variable. It's dependent on it. If you think about like a copilot or codependent, it depends on the other number. Then we have our constants. Constants are numbers that don't change, that can't get changed inside the problem. So like 5 is a constant. 7 and 2 are also constants. You could subtract them to end up with 5, but it is also a constant. And then the main written part of the equation is called the expression, and that is the part of it without the equal sign. We're not putting it equal to something else, but when we put it equal to something else, then we have the equation. Okay, so I want to talk about some steps to solving two-step equations. So first of all, a two-step equation is an equation that takes 2 steps to solve. So for example, an equation is a mathematical statement containing an equal sign. One number is represented by an unknown variable. To solve an equation, the value of this variable must be found. So we're always looking to get whatever the variable is isolated. It wants to be by itself. So we need to go ahead and solve it for that. So the basic rule, whatever operation is done to one side of an equation, the same operation has to be done to the other side. So if I subtract something from one side, I have to do that same operation to the other side. And we're always thinking about doing the inverse of the operation too. Inverse is the opposite of the operation. So for example, in here, a one-step equation is I'm going to divide both sides by 4. And you divide because right now the problem is multiplying, and the inverse of multiplication is division. In the two-step equation, we first of all want to move the constant. So in this one, they're saying add the 10 to both sides because it's the constant. So if I add 10, and the inverse of subtracting is adding. So if I added 10 to that side, that gets rid of it on that side, but I also have to add 10 to the other side, which is where then they now have 6y equals 30. Then my next step is to isolate the variable, which means I need to get that coefficient away from y, and right now it's multiplying again, so the opposite of multiplying is divide. So I divide both sides by 6, and then I get y equals 5. And equations with brackets, this would be that it has some distributing in it. So remove the grouping symbols. So in this case, we want to distribute. So we would end up with 3 times x is 3x. 3 times 2 is 6. So 3x plus 6 equals 24. Then we can go into those same steps that we had up here. So then we would move the constant. So if it's addition on this side, we're going to subtract those. So then 24 subtract 6 is 18. Then the next step is to isolate the variable to get that coefficient away from the variable, which again in this case it's multiplying. So the opposite of multiplying is dividing. So I would take that 18 and divide it by 3, which is where I get x equals 6. Okay, so we're going to practice some word problems today on this and go through these. So in this one, and then find the solutions. And we're also going to practice writing out some word problem examples. So on this one, we have a model where it shows here 4x plus 2 equals 30. So that's our equation. But we want to go ahead and figure out a word problem that could go along with it. So you can just think of anything that could be 4 times the same quantity of an amount. So we could maybe say that, we could say we bought 4 boxes of cereal and plus a gallon of milk, for $2. Our total was 30. So then we want to find out how much was, sorry, I'm running out of room. How much was each box? So then that could be represented by up here, the 4 times X, that would be the 4 times however much the boxes are. We needed to assume that the boxes are the same price, plus 2 equals 30. So then to go ahead and solve this, I just go into my 2-step equation. Remember, my first one is to move the constant, so subtract 2. I'm doing the inverse to move it. Subtract 2, so whatever I do to one side, I'm going to do to the other. So 30 subtract 2 is 28. I still have the 4x on this side. So then, now I want to isolate the variable. So I need to do the inverse of what's going on here, which is multiplication. So the inverse is division. So divide by 4. I also have to do that to the other side. So 28 divided by 4 is 7. So my x, I guess we could put that over here, x equals 7. Okay, another example. In this exercise, we're going to read the context of the word problem, then provide the missing information and solve each problem. So this one says the quotient of a number and -9 is increased by 10. The result is 11. So first of all, we need to know some things. The quotient, remember, is an answer to a division problem. So we need to model that or make that equation. So on here we have the quotient of a number and -9 is increased by 10. The result is 11. So in this case, we have some type of number. So we'll say n. Quotient means divide. So I'm going to say whatever n is divided by 9, increased by 10. That's going to mean plus 10 equals, the result would be equals 11. Okay, so then in this 2-step equation, again, first step is always to move the constant away and do the inverse. So it's plus 10, so subtract 10 from that side gets that cleared out. So then subtract 10 over here. 11 subtract 10 is 1. I still have the n divided by 9, -9 over here. So now I need to get n by itself. And right now the operation going on is division, so I want to multiply the -9 to cancel it out on that side. So I'm going to multiply by -9, multiply by -9. So 1 times -9 would be -99. So then we would know our number is equal to -99. Okay, next example here. Billy is 3 years older than his sister Anne. Together, the sum of their ages is 25. How old are Billy and Anne? So write an equation for this context. Use a model to help you if necessary. So in this context, we could say, so we have Billy is X amount of years, and Anne is X amount of years, but Billy is 3 years older, so we're going to add 3 to his. And then together, they should both equal 25. So we can write an equation, something like x plus 3 plus x, and we're going to kind of keep the x plus 3 together, equals 25. So then we can go ahead and combine some things. I have 2 x's on there, so I can say 2x plus 3 equals 25 to solve that. And then going back to my 2-step, I need to move the constant, so do the inverse, subtract 3, 25 subtract 3 is 22. I still have the 2x. Now I need to isolate the variables, so I need to move the 2, which it's multiplying, so I'm going to divide and divide. 22 divided by 2 equals 11, so x equals 11. So that would be, that's how old Anne is. So Anne is 11, but Billy is 11 plus 3 because he's 3 years older, so he's 11 plus 3, so that would mean Billy is 14. And then show that your answer is correct. Well, one way we can show it is just to put it equal back to 25. So we could say, we could take Billy's age, 14, plus Ann's age, 11, and see, does that equal 25? And yes, it does. So we can leave it at that. Okay, so for one last answer problem on here, I want you to go back and look at this equation again. So I go to the store to buy cookies, milk, napkins, and cups for a party. I need to know how many packages of cookies I can buy and still have money left over. I have $35.50 in my wallet. So we know that's an important number. I have $35.50 in my wallet. I know that I need 2 packages of napkins at $1.50 each and 2 packages of cups at $3.50 each. I need 1 gallon of milk for every 2 packages of cookies. Okay? Each gallon of milk costs $2.50. Each package of cookies costs $3. How many packages of cookies can I buy and still have money left over? So that's going to be your challenge. You will find that challenge on the Jamboard to work on, and plus an extra challenge as well. So go ahead and work through those, and then we will discuss that later. Thanks.